Welcome to this video on equivalent resistance of resistors connected in series with one another. In this video, what we're going to do is essentially show the combined resistance of R1, R2, R3, and R4 as if they were one equivalent resistor. We did something very similar with the capacitor videos, so you might want to go back and check those out. I'm also going to employ the junction rule and the loop rule here, Kirchhoff's loop rule, in order to derive an expression for the equivalent resistance. So let's go ahead and do that. Now remember, we're using conventional current, so we're working from the positive terminal external to the battery here back to the negative terminal. So what I'm going to write is EMF1 minus the potential drop across R1, which would be equivalent to I times R1. That would be the potential drop across that first resistor. So I would do minus I times R1, minus I times R2, minus I times R3, and lastly I times R4. All of this should sum to 0. Now what I want to show is the equivalence here of these parts of the circuit. So I'm going to write here this expression separately from these in order to do that. So I'm going to say that I times R1 plus I times R2 plus I times R3 plus I times R4, all of those together are equal to the total current times the total equivalent resistance. That should be a combined statement. Now, because there are no junctions or no splits here, I can say that the current at any one point has to be the same as the current at any other point, because there's nowhere where the current could have been split and moved somewhere into a different branch of the circuit. So in other words, I is the same in every single term here, and so I can just get rid of I in each of these terms. Thereby show that the equivalent resistance of these three together would be equal to just the sum of those resistors or resistances all added together. So it's a pretty simple statement, and you might want to remember that it was similar to the capacitance equivalence for a parallel configuration. So just be very careful that this is for a series configuration for resistors. But if you were to replace the R with a C here, that would be the capacitance configuration for equivalent capacitance for a parallel configuration. So just beware of that. In the next video, we're going to take a look at how to find the equivalent resistance for resistors connected in parallel with one another.